In the previous lecture, we have covered the topic till electron dot structure. Now we are moving to the next part, that is the characteristics of covalent bonds or characteristics of covalent compounds. Characteristics of covalent compounds. Now, what are the characteristics of covalent compounds? The very first characteristic is covalent compounds have high have low melting and boiling points. Now, why covalent compounds have low melting and boiling point, students? Because the bond between them have less intermolecular forces of attraction. The covalent bonded atoms between the two atoms, दो atoms जब combine कर रहे हैं, उनके बीच में जब वो covalent bond बन रहा है, वो तो strong है. The bond is strong within the molecules, but the intermolecular forces of attraction between them is less. So if intermolecular forces of attraction is less, so the amount of energy to break that bond will be less. That is why they have low melting and boiling points. So what is the reason? The reason is covalently bonded molecules are seen to have strong bonds within the molecule but intermolecular forces are small. So this is the reason behind why they have low melting and boiling points. Next characteristics is covalent compounds are generally poor conductors of electricity. Now, why covalent compounds are poor conductor of electricity? Because the bond is formed between the atoms. जो bond बनता है दो atoms के बीच में, that is formed due to mutual sharing of electrons. That is formed due to sharing of electrons. ठीक है, तो शेयरिंग ऑफ इलेक्ट्रॉन्स की वजह से उनके बीच में कोई भी चार्ज नहीं होता. So the bond between the atoms is formed by sharing of electrons. तो sharing of electrons की वजह से उनके ऊपर कोई भी चार्ज नहीं रहता. तो अगर चार्जेस उसमें प्रेजेंट नहीं है तो क्या वो इलेक्ट्रिसिटी कंडक्ट करेगा? No, they don't have any free electrons to conduct electricity. So the reason is, since the electrons are shared between atoms and no charged particles are formed. कोई भी charged particles form नहीं होता. That is why they do not conduct electricity. So these are the two characteristics of covalent compounds. First, that is they have low melting and boiling point. The reason is because the intermolecular forces of attraction between the particles, between the two bonded atoms is less. So the amount of energy to require to separate that bonds will be less. That is why they have low melting and boiling points. Second, Covalent compounds are generally poor conductor of electricity. Now, for the conduction of electricity, when we can say that a compound is a good conductor of electricity, when they have free electrons, ions or electrons. But covalent compounds is formed by mutual sharing of electrons. So while sharing of electrons, we do not have any free electrons present. No charge is created. So no charge is created. That is why they are poor conductors of electricity. Next topic is allotropes of carbon. Now the question comes in the mind first of all is, what is allotropes? So first we should know what do we mean by allotropes, or you can say allotropy. So what is allotropy? It is the phenomena in which an element, एक element जब exist करता है एक या एक से ज्यादा form में, ठीक है, in its physical state it occurs in more than one form, that is known as allotropes, having same chemical properties but different physical properties. The phenomenon in which the element exists in two or more different physical states with similar chemical properties. They have similar chemical properties. That is known as allotropy. For example, carbon. Carbon elements can occur in different physical state. For example, carbon के allotropes कौन से? There are 3 allotropes of carbon that you are going to study. Diamond, graphite, and Buckminster fullerene. So these are the 3 allotropes of carbons. They have same chemical properties, but their physical states are different. This process is known as allotropy. And the allotropes, what are the allotropes of carbon? Diamond, graphite, Buckminster fullerene. जो उसके different form में exist होंगे उसे हम बोलते हैं allotropes. Now let us see these allotropes in detail. First of all, diamond. So when you see the structural arrangement of diamond, in diamond, each carbon atom is bonded to 4 other carbon atoms. एक कार्बन एटम 4 other carbon atoms से attach है, resulting into tetrahedral geometry. Resulting into tetrahedral geometry. So, diamond structural arrangement, each carbon atom is bonded to 4 other carbon atoms, resulting into the formation of your tetrahedral geometry. This type of arrangement is known as tetrahedral geometry. So, you can write down in this carbon atom, in this carbon, an atom is bonded to 4 other atoms of carbon, forming 3D structure, that is 3-dimensional structure. Okay, forming 3-dimensional structure. So each carbon is atom, एक कार्बन आटम आपका 4 कार्बन आटम से अटैच्ड है, ये कार्बन आटम और 4 कार्बन आटम से अटैच्ड होगा. So this type of geometry is seen in diamond, and because of this type of geometry, they are the hardest substance. They are the hardest substance. They have strong intermolecular forces of attraction between them. Strong intermolecular forces of attraction between them. It is used for drilling rocks because of the hard nature, drilling rocks, and cutting purpose also, cutting of the glasses. It is used. Then it is also used for making jewelries. For making jewelries. Okay, now next we will talk about graphite. As we have seen that in diamond, each carbon is attached to 4 others carbon atom, but in graphite, each carbon is bonded to 3 carbon atoms. In this, each carbon atom is bonded to 3 other carbon atoms, leaving 1 valence electrons, leaving 1 valence electron free. If this is a carbon, this will be attached to 3 other carbons and resulting to a hexagon pattern, hexagonal arrangement. This way, and sheet-like structures is formed. Sheet-like structures are been formed. हेक्सागोन अरेंजमेंट करता है, तो आप देख सकते हो एक कार्बन 3 कार्बन एटम से अटैच्ड है. ये जो मैं सर्कल कर रही हूँ वो आपका कार्बन एटम है. तो 1 कार्बन इज अटैच्ड टू 3 अदर कार्बन, लीविंग 1 कार्बन एज अ वैलेंस. एक कार्बन को ऐसे ही एम्प्टी छोड़ देगा, एक वैलेंस इलेक्ट्रॉन ऐसे ही रहेगा. ठीक है, so they form a sheet like structure. शीट लाइक स्ट्रक्चर्स ऐसे बीच में फोर्सेस ऑफ अट्रैक्शन होता है, उनके बीच में शीट लाइक स्ट्रक्चर्स बनाते हैं. ओके, बिकॉज ऑफ दैट फ्री valence electrons, they are good conductors of electricity. They are good conductors of electricity. Good conductors of electricity, and they are soft and slippery. Soft and slippery. Diamonds were hard, they are soft and slippery because of this sheet like structures. एक sheet दूसरी sheet के ऊपर shift होती जाती है, and that is why they are also used as lubricants. They are used as lubricants. So this was all about graphite. The third type of allotrope is Buckminster fullerene. The third type of allotrope is Buckminster fullerene. And in Buckminster fullerene, you have 60 carbons attached. It is a C60 carbon attached form. It looks like a football. फुटबॉल की तरह दिखता है. इसमें आपके पास 12 पेंटागोनल फॉर्म स्ट्रक्चर्स होते हैं एंड 20 हेक्सागोनल फॉर्म पैटर्न बनाते हैं. और फुटबॉल जैसा स्ट्रक्चर बनाते हैं, पूरा एक क्लस्टर जैसा बनाते हैं. दे all 60 carbon atoms are arranged in clustered form with each other. क्लस्टर फॉर्म में अरेंज हो जाते हैं और फुटबॉल जैसा स्ट्रक्चर क्रिएट करते हैं. फुटबॉल या फिर सॉकर बॉल बोल सकते हो, ठीक है. And they have total 12 pentagons present in them and 20 hexagon present in them. This is a Buckminster fullerene and it is the most stable allotrope form. It is the most stable allotrope form of carbon.